Hello guys, so today I am starting the machine learning playlist. You can check out in the description and you will get all of these details about this machine learning playlist. So basically today is the day one. Here I am starting the machine learning and here I will explain you in depth about all of this algorithm like linear regression, logistic regression, SBM, decision tree, and k-nearest neighbor, DB scan. All of this algorithm I will explain you in depth about this. So let's continue for this. So let's start from starting. Like, what is AI versus ML versus DL versus data science? What is this? Like, you have heard about this name like artificial intelligence, machine learning, deep learning, data science. So now I'm explaining you all of these things. So basically, suppose this green color is the AI. Everything will come under inside the AI. So you know about, I think, the subset, set, subset, all of this. So I'm explaining in that way. So this is the AI. So basically AI to create an application which can perform its own task without any human intervention. Matlab means if you want to do some work without human intervention, if you are able to create a robot like that, which will not suppose which would not allow human to interpret or which will not want help to humans to perform any task, then this is the AI. So now coming to the inside. So now coming to this part, white part, this is the machine learning. So inside the AI you have created some models like machine learning models, which is the like machine learning. Inside this machine learning the deep learning will comes. So deep learning is basically a part of machine learning, and inside the deep learning, there are some algorithms are there like which will mimic the human brains. Like algorithms are there, and this you can see that this is the part for like data science. So data science is basically a combination of deep learning, machine learning, and AI, and other things also, statistics also. So this is it. So now I think you will understand this in a much better way. Example, Netflix recommendation system. You have seen like example like the Netflix recommendation system. So if you watch the movie, then Netflix there's algorithms run behind this Netflix which will suggest some movie related to that movie. So this is not that's it for this. Now coming to the second part, like type of machine learning algorithms. So there is three types of machine learning algorithms are there, like supervised machine learning, unsupervised, and reinforcement learning. So in supervised machine learning, basically if you have a data which will be labeled like labeled means you have a output data also. Suppose there is a data for house price prediction. There is number of rooms and bedrooms are there, like which location is there and corresponding to the price of that room is also available. Then this is supervised machine learning. And if you have a unsupervised machine learning algorithm, then here you don't have a basically output data. So for this to solve this type of machine learning problems, you have to apply some unsupervised machine learning like k nearest neighbor, not k nearest neighbor, k means clustering. Basically clustering algorithms are there, and also there is algorithm called a priori algorithm. You can apply unsupervised machine learning to you to solve this unsupervised problems. And the third one is reinforcement learning. So basically in reinforcement learning, this basically a reward based algorithm is there. And so suppose basically reinforcement learning is used in robotics. Suppose your robot is not performing well, so you say that there's a reward and penalty based algorithm. So if the robot is doing good, then you give him some reward, and if it's not doing good work or well, then you give some penalty to this robot, so in the next time he will work well. That's for like reinforcement learning. Supervised machine learning, there are two types of supervised machine learning: regression and classification. Regression means basically your data has a classes. No, 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 sorry. In regression, basically you have a continuous class value, continuous values. Like if the house price prediction means price will be a continuous value. And for classification, suppose there's some problems are there, like cancer detection. If you have cancer or not cancer, spam, male spam or ham, then this is a classification algorithm. You can categorize in this category. Predict house price, yes, I have already said that. Suppose there is a size of house and number of rooms, then this is the price. So this is algorithm is basically goes into the regression problem. Right? There's some dependent or output features are there. Continuous for regression, categorical, classification. So if your output has a categorical, then it's a classification algorithm. So basically this is a classification algorithm problem. So if you have a number of hours study, number of play hours, like games play, then what is the probability to pass or fail? So this is a binary classification, or we can say the multi-class classification. If we maybe is also there, so this is a multi-class. If your output has a binary two classes, then we can say it's a binary classification, and it's have a more than two classes, then we can say a multi-class classification. And this the output feature, you can say a dependent feature. Basically this is a independent. Basically this output feature depend on something, so this is, that's why we say it's a dependent on something. And these are independent, these are not depend on anything. And unsupervised machine learning, so like customer segmentation and clustering, like I've already said, the k-means clustering algorithm, you can apply a priori algorithm. Like suppose this is an algorithm where this is a salary and spending. According to like the salary is low, then spending is low. Salary is somewhat high, then it is this like this. So this is basically used in big companies. Like suppose you want to sell something, suppose Amazon is a website. So basically, according to this, they will recommend you something. If your salary is high, then they will suggest you some product which will be a high price, something like that. If your salary is no, like Amazon knows your salary, like they have your balance, everything, so they know. That's why they will suggest you based on this spending score. Basically, model will train on this data. So in supervised machine learning algorithm, these are the algorithms that they will become under the supervised machine learning, like linear regression, logistic regression, ridge and lasso. So basically, ridge and lasso not algorithm. Basically, it's a regularization. Like if your model has been, we can say that overfitted, then we can use a ridge and lasso to optimize this algorithm. And elastic net, logistic regression, decision tree, random forest, ADA boost, XGBoost, and both classification and regression we can use. Basically, linear regression is for classification, no, regression, and logistic regression for classification. And this like decision tree, random forest, ADA boost, XGBoost we can use for both classification and random forest, like for regression. And unsupervised machine learning, basically in unsupervised, under the unsupervised, these are key means clustering, hierarchical means clustering, DB scan clustering. These are the algorithms we will learn basically in this playlist. Now go comes to the linear regression, and then we will learn about ridge and lasso, like how to overcome this overfitting problem. And reinforcement learning is also we will touch some part. Now coming to this simple linear regression problem. So basically you have trained a model. If you give some like x value, x means your input, then your model will predict some height according to that. not height, it's weight. Basically your model is nothing but a weight matrix inside your model. If you pass input, then it multiply and give you some output according on the basis of training data. So data set is weight and height is there. If you the weight is this one 74, then the height may possible something like that. So if you train a model on this, your model will look like this. Like weight is there, height is there. Then so basically your aim is to predict a best fit line that can basically which will come touch every point, but this can't be possible कि you will touch to every point. So in linear regression basically we create a best fit line according to by applying a gradient descent optimization function, and basically we apply a loss function. Basically we want to reduce the loss function of this problem. So by applying again and again this gradient descent, we will get a best fit line. So we will see like how this work. So basically this intercept is there x0 and theta 0 theta 1 x. We can say that like you can represent in any form by equal to mx plus c by equal to beta 0 plus beta 1 x h naught theta x equal to theta 0 plus theta 1 x. You can write in any manner which will you will get a good understanding. You can write it, that's not a problem. So basically they have written as theta of x equal to theta 0 plus theta 1 x. According to this we will now learn from this algorithm, and our error is basically h minus h of predicted by not so sorry by minus by predicted. By is the your actual value and by bar is basically a predicted value. This is your cost value, and by summation of this all of the cost value we will get a loss. Cost means basically for cost for one point only. If you are finding a error between one point, then this is a cost function, and if you find summation of all this cost function, then you will get a loss function. So cost function is this basically, and if you apply a summation, then this will be a loss function. So the function loss function will be a 1 upon 2m summation of I equal to 1 to m h theta of xi minus yi ka whole square. Basically this is a mean squared error, you can also say MSE, and a loss function is also. And cost function is basically a cost for only one point if you are finding, and you in your mind the there will be some confusion like why we are dividing 1 by 2m. So basically m, you know, like m is for to finding the mean of your error, but why is 2? So you will get some confusion, like so I will explain you like in at the time of derivation of this function cost loss function. So basically there's a 2. If you derivate this function, then 2 will come here, and 2 by 2 it's become 1. That's why they have written like this. So now in your minds the question will arises like what is this cost function, what is gradient descent. So basically gradient descent will help us to finding the global minima in a minimal time. So now comes to you, I think you will understand this one. And now I'm explaining like how to find a best fit line. So to find a best fit line, suppose this is your cost function, like this is your gradient descent formula function is there. So the gradient descent function formula, I think it is written here or not. Yeah, it's written here. W nu basically the formula is W nu minus W old minus alpha. Alpha is the basically a learning the differentiation of cost function with respect to W. This is your formula to finding the like gradient descent. So now I am explaining. So basically in the starting firstly we take any m value, and corresponding to any m value we will get some error. Error means a cost value, cost function. So suppose at the starting, this is, suppose you have taken some values like this, and after like applying this formula, you will get some error. Suppose you have taken m equal to 3, and you will get this error. So suppose here, suppose 2, you have taken m is basically a slope, so you will get this error. But you have to find this. So basically at the starting you will start any random m value, so you will start at 2, but at the second number, this is for first epoch. In the second next epoch, basically we will apply this formula again, and basically this formula, you can say that negative is there, and if you find a derivative of this cost function, the this formula here, you can see that it's a positive slope. Positive will came, and again your like m old minus some value, so this time your m will be reduces, like will came here. So apply again and again, running number of epochs, you will get this local global minima by applying this formula. So this is the use of this gradient descent function. Basically gradient descent is nothing but a cost function, or we can say a loss function, representation of your loss function according to different m values. So to reaching the global minima in a minimal time, we will apply a gradient descent. To start this gradient descent, we will randomly start from any m value, and according to this formula, your convergence will happen. And this is a learning rate. If you like learning rate, you will take in like 0.001, like some small value. If you take some high value, then you have seen that is like very much jump is there. So if you take some higher value, then your convergence will not happen. So that's why we have taken some small values for alpha. Alpha basically a learning rate. Learning means rate means how you are learning, like how fast you are learning. Basically for this we will take some small values to learn, to see the accuracy of this model. And that's it for gradient descent. And convergence algorithm is there, like w new equal to w old minus, I have already said, this is the formula, w new equal to w old minus alpha. And there's a, you have seen that 1 upon 2m, but the derivation now is there, so you will not see that, like 2 is come below, and 2 by 2 cancel, alpha by m, and summation of h of theta means predicted value minus actual value. And this is for your constant. You can see that if you apply same formula and apply differentiate with respect to c now, like constant, then you will get this equation. Repeat until convergence means if you repeat this formula until you will not get a global minima. So that's it for this convergence and for gradient descent. Now coming to multiple linear regression problem. So in multiple linear regression, basically there is a multiple independent variables are there, and like theta 0, theta 1x, and something like that. So this is the formula, theta 0, theta 1x, theta 2x, theta 3x, like multiple linear regression is there. Now coming to the performance matrix used in linear regression. So in linear regression, to find the performance, so we can say the accuracy, we use R square and adjusted R square matrix. So R squared formula is 1 minus SSRES by SS total. SSRES means the sum of residuals. Sum of residual means sum of error, and sum of total. So sum of error of total. So the formula is looks like sum by minus by predicted means residual means error by my actual minus predicted by minus mean total error. Total error comes by actual minus mean. So this is the formula, and if you find put this value in this equation, then you will get some accuracy like 0.70. 0.70 means 70%, 85%, and 90%. So now this there is a some confusion between there is like, what if our like numerator will be greater than denominator, then this will come to a negative value. So if you designing any problem, we will suppose that you will not create a alg- algorithm, or we can say we will not create any algorithm that will be worse than this mean value. If you this is basically a mean equation, mean line. So if you create a algorithm or be a best fit line, if it burst then this line, then what is the use of your problem? Like you have, why you are using? So that's why it's always be greater than, like denominator is always be greater than the numerator. If it is not, then your model is very worst. And now coming to the adjusted R square. So adjusted R square is basically the formula is 1 minus R square into n minus 1 upon n minus p minus 1. So now the n is the number of, basically we can say that a number of data points, and dividing by the n minus p minus 1. N is the total number of data points. P is basically a predictor. Here we can see that 1 n minus 1 upon n minus p minus 1. So p is basically number of independent feature, or we can say that are predictors, independent variables, you can say that. So that's it. And some like why we are using adjusted R square, this will also maybe comes in your mind. So basically suppose if your problem have something like that, there's two variables like number of rooms and the number of rooms is there, and suppose the second feature is bedrooms there and location is there. If you have a only one independent bed like number of rooms, then there is a price, then your accuracy will suppose come 85%. And you have added a second feature like location, then location is also like a dependent, like a good feature which will increase your accuracy like 90%. And third time you have added a third feature like sex means this is like gender, we can say that it's a male or female. So this is not a dependent feature. Like what is the use of gender? Like what we can say, like a male will buy whom or a female? What is it? Like this is not a correlated basically. So, but still your model will get increase, accuracy will increase like 91%. So that's why the adjusted R square will comes in the picture, and here we are dividing n minus 1 upon n minus p minus 1. So basically number of predictors is come, but so here if you increase this number of predictor and the gender you have added, but this will not increase your accuracy. Still it will be a same, or maybe some decrease, or maybe some point will increase, but not as increase as R square is increasing, or maybe it will decrease. So that's why adjusted R square will be used many times to finding the performance of a matrix, or we can say that the accuracy of a model. Now coming to the overfitting and underfitting. So there is basically a three types of model. Basically overfitting, underfitting, and best fit, or we can say that overfitting, underfitting or good fit, we can say that. So in overfitting, basically your model is performing very well in training. Suppose you have created a model which will touch every point. Suppose your feature is a linearly separable, and everything is coming in a line. Then your model is very good, like overfitted, like 100% accuracy. And at the time of testing, you will not getting a good accuracy. So that's, we can say that overfitting. Or overfitting in terms of machine learning, we say that low bias, high variance. Low bias means basically error in the training, and by variance means the testing error. So basically in that overfitting, your bias is low but variance is high. And underfitting is basically your model is performing well, not like overfitting is there. And underfitting means your model is even not performing well in training and not even performing in testing. So this is the condition of underfitting. So in underfitting, basically your model will be a high bias and a high variance. The third type of model will come is basically a good fit, we can generalized model. So in that, basically we have a low bias and low variance. That's for it. Now tomorrow we will learn about polynomial regression, MSE, MAE, RMSE, and also we will learn like region loss, so like how to prune the overfitting. Like if your model will be overfitted, then how to overcome this overfitting. So we will learn in the next lecture. Thank you guys for today. I think I am explain linear regression in a good way. Now let's meet tomorrow. Thank you guys.